We're gonna discuss some of the applications of differential equations. The first application I want to discuss about is mixing problems. Mixing problem is a pretty common problem where people use differential equation to model or to measure the concentrations of a certain substance in an object. For an example, if you have a tank that initially contained pure water, and people want to add a mixture of a chemical substance into the tank at a certain rate, and then the water or the mixture will come out with a certain rate. And the question raised is at a certain time t, for example after 2 minutes, what is the concentrations, how much is the concentration of that substance, of that chemical substance is contained into the container. And then in order to solve that problem, people trying to use differential equation to set up a differential equation so then it can measure the rate of change of the chemical substance in terms of time, and the rate of change of the chemical substance is measured using a law when the rate equals rate in minus rate out. So what is rate in? Rate in can be measured using the flow rate multiplied to the concentration of the chemical substance. And flow rates are in concentrations of the chemical substances can be called at C in. And what is rate out? Rate out is equals the flow rate again multiplies to the concentrations of the chemical substance at that time t, and flow rate out is called R out, and the concentrations equals the amount of the chemical substance divided by the volumes of the amount of the water, of the mixed water in the tank at a certain time. Following that, we can look at the first example in our lecture notes here. So in the first examples, you can see that the initial volumes is 120 liters. The tank initially contains 120 liters of pure water, so the initial volumes is zero. Initial volume is 120 liter, and then now we can try to come up with the rate in function. So rate in is equal concentration times the flow rate, and concentrations here is gamma grams per liter, and the flow rate is 2 liters per minute, because it's a salt water solution containing gamma grams per liter of salt enters a tank at the rate of 2 liters per minute. So the concentration should be gamma and the flow rate should be 2 liters per minute. And you can see it here. The units are cancelled out nicely because the unit for the concentration is gram per liters, and units for the flow rate is liters per minute. And then after cancelling liters and liters, the final units is grams per minute, which makes sense, right? Because the rate of change of the chemical substance in terms of time should have the units grams per minute. That's the rate in. And how about rate out? So the rate out again is going to be equals the flow rate multiplies to the concentration of chemical substance at time t, and flow rate is the same as the flow rate in which is 2 liters per minute, and the concentration should be equals y divided by the volume of the mixture at time t. Y is the chemical substance at time t, and the Vt is the volume of the mixture at time t. So y equals V of t should be the concentrations of the chemical substance at times t. And when we combine the rate in and rate out together, we will have the rate is, we will have the rate of change of the chemical substance equals rate ins minus rate out, and then you will have the initial values of the volume, initial values of the volume of the mixtures should be 120 liters. And following this, we can find the volume, the rate of change of the volume, which is 0 because rate in equals rate out. And then plug in the initial values, you can find C equals 120. That means V of t is here will unchanged and should be 120 liters all the time because rate in equals rate out. Please take a note here later on. If you have a problems when the rate in is different to rate out, then V of t should be a function of t, not just a constant. And in this case, to make it easier, the constant rate in equals a constant rate out. That's why the volume of the mixture in the tank will always 120, would never change. Now, let y of t be the amount of salt in the tank at time t. And t's units of yt should be grams and units of t should be minutes. And we have at this point, we should have a differential equations which measuring the amount of salt at time t equals 2 alpha minus 2y divided by 120, which is because rate ins is 2 gamma and rate out is 2y divided by 120, and we have an initial value which is y0 equals 0. Where did we get this initial values? Is from the assumption at the beginning that the tank initially contains 120 liters of pure water. That means when t equals 0, the amount of salt is 0. So that's why the initial value is y0 equals 0. And then our next goal is to solve for this IVP. And this IVP here can be written as this following equations. And in order to solve for this IVP, we should solve for the general solutions first and then use a specific point to find the particular solution. And to solve for this, to find the general solution, you can use either separable equations or integrating factors, whichever way you use, but in this one I'm going to use separable equations here. And then you separate two values from both sides, and then you get a functions of y in terms of c and t. And then you're going to use the initial point 0, 0 to solve for c, and eventually c will be equals 120 gamma. And plug everything together, you can find the equations that measure the amount of salt at time t, which is yt equals 120 gamma times 1 minus e to the negative 1 over 60t.